And here we go again with another video brought to you by Multimedia Science. This time it's the Newton's Second Law Simulation Lab. The Newton's Second Law Lab software is a simulation of an air track. A force will be applied to a mass on the air track which will accelerate it. You will investigate the effects of the force and the mass on the acceleration of the mass. So you will be dealing with three variables. You will be essentially running two experiments. One, the force, the x variable, versus the acceleration, the y variable. And two, the mass, x variable, versus the acceleration, the y variable. The objective of the lab is to find the relationships between F and A and between M and A, and to derive an equation that relates all three variables. Let's take a look at the lab. So here we can see here's the simulation of the air track. You can assume that this is a relatively frictionless way to move a mass. In this case, it's a slider. The slider will start at initial velocity of 0 and accelerate down the air track due to the force or the weight. There has to be a way to measure the acceleration, and the way that typically is used is there's a flag of known length that's on the mass, and it goes through a photo gate timer, which measures the time it takes for that flag to pass through the photo gate. That means that you now can determine the final velocity. And from the initial velocity of 0 and the final velocity, and knowing the distance on the air track, you can figure out the acceleration of the mass. Now there are three simulations. You can use one for your lower level classes because the force is a force. It's 5 newtons, 10 newtons, 15 newtons, which of course is not the way it works. You have to put a mass to create the force due to gravity. And simulation 2 is the same. The difference is that simulation 1, the output variable is the final velocity of the slider. There's no real calculation involved to figure out what this final velocity is. In simulation 2, you have to take the flag and the time and calculate out the final velocity. And finally, in simulation 3, this is the actual experiment as it should be run. Now you've got the mass. You have to figure out what the force is. And if you want to keep everything the same, you have to take the masses that you change and place them on the mass here to keep the variables in sync. So simulation 3 is much more complicated. Running the experiment, just like in the real world, is pretty simplistic. You're going to choose a value for the mass and the force, and you're going to start the air track, and you're going to read in this case, the final velocity. Reset the air track, change your variables, start the air track. I found that the students found the time and effort to set up the air track and the difficulty with running the experiment pretty boring. So I found that the simulation was just as interesting to the students, and they got the idea pretty quickly. I would often put out the air track. We had it in our classroom. Often took a fair amount of maintenance to keep it going, and just having the air track there for the students to see was pretty much enough. There is a set of directions which lead the students through the way of running the experiment, and also gives them a blow by blow of what the air track looks like and how it works. Go back to the main menu. Here is the second simulation. Same thing. We'll choose some variables. We'll start the air track. You can see now you've got the time that it took the flag to go past the photo gate timer, a little bit more complicated calculations. And finally, simulation 3, where you've got a mass hanging, you've got two masses here. You've got the accelerated mass, and you've also got the mass that goes along with the mass that's doing the acceleration. In other words, the mass being accelerated is both the hanging mass and the slider mass. Here we can change both the slider mass, the added mass, and the hanging mass, and this has to be done in such a way that, of course, they're balanced, that as you change it, that you keep the slider mass, the hanging mass the same between the hanging mass and the accelerated mass. So that's the Newton's second law lab simulation. Along with that, there are some handouts. The lab report. This is the answer key. It's broken up into 4 parts. You can either allow each student to fill the whole thing in. It does take some time, both to take the data and to do all the calculations. So I would often, especially for the lower level classes, I would break it up into 4 parts. Partner 1, responsible for data, taking the data and the data tables. Each section has a set of questions. Part 2 is doing the acceleration versus the force, answering some questions and making the graphs. Part 3, acceleration versus mass, answering some questions and making some graphs, which a little bit more work for that particular partner. And finally, partner 4, combining everything together to see that the acceleration is proportional to the force divided by the mass, and doing a final calculation and graphing F divided by M versus A, which comes up with the equation F equals MA. And as you can see, all of the data fits on a straight line, proving that that equation is correct. So it's a nice lab. I hope you've enjoyed watching the video. Thank you. Oh, I almost forgot. If you're interested in Newton's second law simulation, please go to Teachers Pay Teacher at this URL. You can also find a number of other physics, chemistry, labs, games, challenges, experiments, and also a number of teacher tools.